right, this is another homework problem, and the solutions are out there. I'm going to send it to you, but I also am going to show you how to do one of these problems and calculate SSE. I'm not actually going to use all the data. I'm just going to use a little bit of the data so that it's feasible for me to calculate it and you to see what's going on. So again, I'm a table person, so I'm going to put in here the data as a table. So 0, 2.5, 5.0, and let's just use 4 data points. We're going to redo this problem. Stress. This is like stress and strain, a physics problem. So not the kind of stress that we have as cadets. And then like put that in. And then I would also generate a plot for this. And let's see how to do this. The data goes up pretty fast to 90. So I'm going to actually go in 20s on the y-axis. And on the x-axis, I'm going to go from 0 to 10. So this is a sloppy graph. So this is my x-axis. This is load. And then my y-axis, I'm going to put stress and have it go up by 20s. 20, 40, 60, 80, 100. Just so I can see what it looks like. So at time equals 0, I'm a little bit close to halfway. That's my first dot. That's that point right here. And then 2.5, that's about halfway through. We're about here. And then that's my second point. And the third point is at 5. I'm at a little bit over 60. It looks linear to me with my sloppy graph. And then when I'm at 7.5, which is right around here, I'm close to 100. So something like this. My sloppy graph looks like it's linear. And now you're asked to define those variables. So in green here, let's put y is stress, x is load, and I'm going to put x is equal to the load and put the units in KNs, and y is stress in MPa, and this is my explanatory variable because it explains, and this is my outcome variable or response. I should say response. Now, the first step is to generate a line from this. So you're going to fit this with a line. So that's our old y equals mx plus b. So we need to calculate m and b. B is for free sitting here. B is 9.6 because the y-intercept is there. If they don't give you a 0 data point, you don't have that, but we have it for free. And now we just need 2 points to make m. M is y2 minus y1 over x2 minus x1. So let's deface here. Here's my x1 and here's my x2. Yes, you can use the 0 again. 0 is great. Here's my y1 and y2. I'm just labeling and defacing my table. I'm going to make another line here because I'm about to do some more stuff with this. But now I can crank this through. Every time I say crank, you probably should laugh. There's actually something called a mathematical crank. We can talk about it in class. There's my y2 minus y1 and my x2 minus x1. And then that turns out to be, let's see, parenthesis, this guy, 3.5 or 35.3 minus 9.6. You can't see the typos I'm making, but I'm making typos, so it's taking me a little longer. Divided by 2.5. This is 10.28. That's my slope. So here's my formula. My y is equal to 10.28x plus 9.6. Now, how good is my prediction model? That's the next step. So that's what really I was after here, is I wanted to show you how to use SSE and R squared. So let's pull this, now that I know how to do this, over to another page so we can do the SSE work. There's the data again. I got better at doing this, thankfully for you. And I'm going to erase this stuff. I'm going to go back here though and pull my model, which was this guy right here. And on the next page, I'm going to put it right up here. Okay, so now I have my model. All I have to do is put the predictions here. So here is predicted. So I have 9.6 is for free because it's the y-intercept and I already used that point. And I also used this point to fit. So this is going to be 35.3, but we can just double check it. We just put in for 2.5, we're going to put into the formula y is equal to 10.28 times 2.5 plus 9.6. Sorry, that water rushing is my husband trying to clean out something. And I get 35 point, sorry, here, 0.3. So I do get the same thing. Let's now do the x equals 5. Y is equal to 10.28 times 5 plus 9.6. And this is going to be faster because I already have it typed in. I'm going to put 5 in here now. And I get 61, so not exactly 61.2. And then now I'm going to put in x equals 7.5. Y is equal to 10.28 times 7.5 plus 9.6, and I get 86.7. All right, so those are my predicted, and I'm not going to make the whole table. I'm not doing exactly this problem. Now that I'm done with that, I have to calculate the error. So this is actually a pretty hefty calculation. You won't be copying and pasting, but get some scrap paper if you need. The one thing you need is paper to do these by hand. So I'm going to go here, paste this table, and over here I'm going to erase. I'm going to move this over a little bit. I'm going to erase this. Well, I'm going to erase that, and then I'm going to put in an extra column which is error and error squared. So save these calculations for the end because they do take time. The error is going to be the difference between the actual, which is right here, and predicted. So it's actual minus predicted, A minus P. So the error here, we have 0 for the first one, 0 for the second one. The third one, however, I get 61.2 minus 61. Actual minus predicted is 0.2, and you could see that. You don't need a calculator, but if, whatever whatever makes your crutch better for you so you get the right answer. Go ahead and use it if you have to. Don't no one's judging you. We get 3.4 here. Next step is to put these guys squared. 0 squared is 0, 0 squared is 0, 0.2 squared is 0.04, and I did that on a calculator because I'm not thinking. And then 3.4 squared is 11.56. And then these guys here, to get some squared error, it's going to be the sum of these guys, 0 plus 0 plus 0.04 plus 11.56. You're going to take those guys and add them all up, and that's your total error. All right, so how do you get from there to r squared? I'm going to cut this off and put that into another video.